Hi class, here are the notes for Inequalities Day 2. Now I'd like you to try the warm-up so you can pause and solve these equations. This is from last semester and it'd be good review. And then you can watch me do them after you've taken a try at them, okay? Okay, so go ahead and pause and give them a try. Number 1. We have x minus 5. Well, this is a minus 5, so remember to solve we have to add 5 to both sides. And that gives us x equals 12. And we're done. Now here we're multiplying negative 4 times x. So the opposite of multiply is divide. So we're going to divide by negative 4. And that's going to get rid of the 4's on this side, and we get x equals negative 12 divided by 4. So 12 divided by 4 is 3, and a negative divided by a negative is a positive, so it's just positive 3. We're done. Number 3, we're going to notice that x is being divided by negative 3, and the opposite operation of divide is multiply. So we'll multiply both sides by negative 3. That will undo the division, so we end up with x equals, and 6 times 3 is 18, and it's a positive times a negative, so that's a negative 18. And we're done. And number 4, we see that x has a negative in front of it, and if you remember my trick, to make x positive, we can just multiply by a negative sign. We're really multiplying by negative 1, but multiply by negative on both sides. So negative times a negative makes that a positive x, and 10 times negative is negative 10. 5 is going to be a fraction. Here we're multiplying by 7, so we're going to divide by 7 to get rid of that 7 on both sides. We get x over here, and we just get 15 over 7, and we're done. Okay, 6, 7, and 8 are two-step equations, so we'll have to do 2 steps. Remember, we're trying to get x by itself, and these are best friends right here. The 3x is our best friends, so we need to get rid of the minus 7. The opposite of minus 7 is plus 7, so we'll do that on this side and this side. That cancels, and we get 3x. Bring down the equal sign. 11 plus 7 is 18. That's the first step. Second step now, we see that these two need to be separated. This is 3 times x, so the opposite of multiplying or times is divide. And that will get rid of the 3 on this side, and then divide by 3 on this side, and 18 divided by 3 is 6. And there's our answer. Number 7, we'll do 2 steps as well. Remember, these two are going to stay together. Best friends. So we need to get rid of the plus 3 first. So we're going to subtract 3 here and subtract 3 here. So I'm going to cancel out that, and we get x over 2 on this side. Bring down the equals. We have negative 5 minus 3. So I look at negative 5. And then I'm going to go to the left 3 more. 1, 2, 3. And I get negative 8. Okay, that was the first step, subtracting 3. Now we need to get x by itself, separate these two. X is being divided by 2, so we'll do the opposite, which is multiply, and that will undo. And multiply this side by 2. So we get x equals, and then negative 8 times 2 is 16, and it's a negative times a positive, so it's negative 16. Number 8 is the funky one. I always call it funky because we're not going to add or subtract first. This right here is in the top of the fraction, so it needs to stay together. These need to be the best friends. So we need to get rid of this 3 in the denominator first. So over here we added first, over here we subtracted first. But here we're going to have to multiply by 3 first to get rid of that 3. So I'll multiply this by 3, and that's going to undo that division there. And multiply this side by 3 as well. So we get x plus 4 over here, and then 10 times 3 over here, which is 30. Okay, so now we've gotten rid of that fraction by multiplying both sides by 3. And now we can get rid of this plus 4. We'll subtract 4 here and subtract 4 here. And x equals 30 minus 4 is 26. And that was a review of equations. And we're going to need to know how to do these steps because we're going to be using them today when we're doing inequalities. So on Monday we looked at inequalities, graphing them on a number line. This is all the numbers v, or is that a y? I can't tell. I think it's a v. All the numbers that are less than or equal to negative 4. So this is our boundary. We're going to put a bubble at negative 4. And we want all the numbers that are less than that, right? This means less than or equal to. So we're going to go to the left and shade that all in. We want all the numbers that are less than negative 4, but we also want the numbers that are equal to negative 4, so we're going to fill in the bubble. Remember, when you have the equal sign, you fill in the dot because we're going to include that in our solutions. Okay, number 2, we're given the graph, and now we're going to write the inequality. So remember, we want to pick a variable. I'm going to pick x. We want all the numbers that are, look at this graph, all the numbers that are greater than 5, right? All the numbers that are greater than 5. So all the numbers that are greater than 5. Now the bubble is not filled in, so that means we're not including negative, oops, that's a negative 5. All the numbers that are greater than negative 5. So because the bubble is not filled in, then we don't include it. We don't have an equal sign here. We just have this. Okay, so that was a little bit of review for Monday. All right, so let's look at this inequality here. 2x plus 5 is less than or equal to 11. So this is not exactly like this up here where it's already solved. And it's not exactly like this one. It's not simple. We have 2 times x, and then we're adding 5. So what we need to do is we're going to eventually solve this so that we only have x all by itself. But before we do that, let's see if these numbers are solutions to this inequality. And the way we do that is we're going to take 2 and we're going to put it in for x. So 2 times 2 plus 5. Is that less than or equal to 11? Well, we're going to multiply 2 times 2 is 4. Plus 5, is that less than or equal to 11? Well, 4 plus 5 is 9. Is 9 less than or equal to 11? 9 is less than 11, so this is true. So this is a solution. Yes. Is negative 3 a solution? Let's put negative 3 in for x. So 2 times negative 3 plus 5, is that less than or equal to 11? Well, we get negative 6 plus 5. Is that less than or equal to 11? Well, negative 6 plus 5. Negative 6 plus 5. 1, 2, 3, 4, 5 is negative 1. Is negative 1 less than or equal to 11? Is negative 1 on the left side of 11? Yes, this is less. So this is also a solution. Is 3 a solution? Let's put 3 in there. 2 times 3 plus 5, less than or equal to 11. Okay, well 2 times 3 is 6, plus 5 is less than or equal to 11. Is 11 less than or equal to 11? Sure, it's not less than, but it is equal to. So this is a solution as well. And notice we have more than one solution. We have x equal to 2, x equal to negative 3, and x equal to 3. With inequalities, we're going to have more than one solution a lot of the time. All right, let's just check, is 5 a solution? Put 5 in for x. 2 times 5 plus 5. Is that less than or equal to 11? Well, 10 plus 5. Is that less than or equal to 11? Well, 10 plus 5 is 15. that is not less than or equal to than 11. So no, this is not a solution. So 5 is not a solution. So our solutions here are 2, -3, and 3, and there's many more. There's an infinite number, but we don't know exactly what they are. We want to get them all. So we're going to solve, quote, solve the inequalities, just like we would solve equations. So let's watch what we do. And let me just mention right now, there will be one exception. We are going to use the same rules to find the solutions to these inequalities that we would use to solve equations, with one exception, which I will show you in a little while. All right? So we're going to use all the same rules to solve these as we did to solve these equations up here. Let's look at number 1. We have x plus 3 less than or equal to 1. So there's a lot of numbers that will make this true. Let's find out what those numbers are. So what we need to do is notice that x is being added to 3, so let's subtract 3 to get rid of that on this side. And we'll also subtract 3 on the other side of the inequality symbol. So we get x, and we bring down the inequality symbol, and then we do 1 minus 3. 1 minus 3, 1, 2, 3, and we get -2. So now we have x all by itself because we subtracted 3 from both sides, and this is our solution. X, all the numbers x that are less than or equal to -2. So if you were to put -2 in there, it would work. If you would put -3, -4, anything smaller than -2 would work there. All right, number 2. Let's solve this. Let's quote, solve this for x. We're going to add 6 because you see that we're subtracting it. So we're going to add it to both sides. And that's going to get rid of that. And we get x all by itself, which is what we want. That is what we want. X, bring down the inequality symbol, is greater than 5 plus 6. 5 plus 6 is 11. So we want all the numbers that are greater than 11, and that will be our solutions for this inequality. Any number that we put in that's greater than 11 will work. 11 won't work, but 12 will work, 13, 14, 15, anything bigger than 11 will make this inequality true. Last one. This is a 2-step. Here's our variable x. We see that 3x are together. Those are just, we're going to still think of them as best friends. We're not going to separate them until the end. So we're going to get rid of this -5. So we're going to add 5 to this side of the inequality and add 5 to this side of the inequality. That gets rid of it here. So we have 3x. Now bring down that inequality sign. And then we have 13 plus 5, which is 18. So we have 18 greater than or equal to 3x. We need to get now this x by itself. It's being multiplied by 3, so divide by 3. And we'll get x here. Bring down that symbol. And we get 18 divided by 3. Use your multiplication chart if you need to. 18 divided by 3 is 6. And there's our answer. Now, remember, I always like to have the variable on the left. So if we want the variable on the left, especially when we're graphing down here, we want to flip everything. So we're going to put the x on the left, flip the sign, completely flip it, and put the 6 over here. Okay, so this is the answer, but I like this. I like it better written like this, with the variable on the left. Okay, hopefully you're getting better at that. Okay, we'll keep working on that. Okay, sometimes we're going to solve inequalities and we're going to graph them on the number line. We could have graphed all of these, but instead we're going to just go ahead and do a couple of them. So we have x divided by 2 is greater than -1. If we're going to solve this, we have to multiply both sides by 2 to get rid of that. And we get x. We're going to multiply this side by 2. So that's x is greater than -1 times 2 is -2. Right? 1 times 2 is 2, and then it's a negative times a positive, so it's negative. So we've solved it. All the numbers that are greater than -2 will make that inequality true. So we're going to put a bubble. How do we graph this? We're going to put a bubble at -2. And we want all the numbers bigger than that, so bigger is to the right. So we're going to shade to the right. Right? And do we fill in the bubble? No, because this is x greater than negative 2, not equal to. We're not going to include negative 2. That's not part of the solution set. Okay, and we'll do one more. We have the variable right here. We need to get it alone. So remember, these are best friends. So we're going to subtract 4 to get rid of that. And we get 2 less than or equal to, right? We get 6 minus 4, which is 2. Bring down the inequality symbol, and we have 2x left here. Now these best friends have to get separated. Okay, so we have, notice that 2 is being multiplied by x, so let's divide by 2 to get rid of it. So we get x over here, and we get, bring down the symbol, and then we have 2 divided by 2, which is 1. Okay, so there's our answer, but we don't want to leave it like that because we're going to graph it, and it's much harder to graph it if the variable is on the right. So we're going to flip it. Flip everything. So the x comes on the left. This sign has to flip. This is less than or equal to. We're going to make it greater than or equal to, and we're going to put the 1 over here. And notice the big wide side is on the x here, and the big wide side is with the x here. That means that we did it right. We flipped it right. So this is how I want to see it written with the x on the left. Now, we're going to graph this. We want all the numbers greater than or equal to 1. So we'll put a bubble at 1. And we'll shade to the right because those are all the ones that are greater than. And we're going to fill in that bubble, because we want all the numbers that are greater than 1 or equal to. So we do want to include 1 in our solutions. And that's the graph. Okay, so that's how we solve inequalities, just like we solve equations, same steps. The only difference really in this case is that the answers that we get are going to be a lot of numbers. When we solve equations, we generally only get one answer. There's some exceptions to that, but we're not going to talk about this right now. But for the most part, we just get one solution in our class right now for equations. But for inequalities, we get lots of solutions, lots of choices that will make the inequality true. Now, there is one exception. When we are solving inequalities, we have to check, we have to be very careful about one thing. We can follow the rules except for when we multiply or divide by a negative number. We're going to have to do something special. So we haven't done that yet. In all of our examples, we haven't had to do this yet. But now I'm going to show you when you have to do this exception. So when we divide by a negative number to solve inequalities, we're going to need to flip the sign. If we don't, we're going to get the wrong solution set. So when we're looking at number 1, for instance, we have negative 9m is less than or equal to negative 18. Well, to solve this, I'm going to divide by negative 9 and divide by negative 9. But notice we are dividing by a negative number. So because of the way that the inequality works, we need to copy down the variable, but we need to flip this sign. This is less than or equal to. We need to make it greater than or equal to. And then we have negative 18 divided by negative 9, which is a positive 2. And now this answer right here will represent the correct answers for this inequality. If you don't flip this sign when you're dividing by a negative number, your answer solution set will be wrong. It's just a quirky thing with these inequalities. So let's do number 2. We need to get p by itself. It's being multiplied by negative 6. So to solve this inequality, we need to divide by negative 6. And we get p on the right. But we've divided by a negative number. So we do need to flip the sign. So it was a less than symbol. I'm going to make it a greater than symbol. And then 12 divided by 6 is 2. Negative divided by negative is positive. So there's our answer. Now remember, we divided by a negative number to solve this inequality, so we flipped the sign. So we did flip it. But please remember, I also want you to put the variable on the left. So when you write your final answer, I'd like you to put p here. You're going to flip everything. P less than 2. We're just going to make the variable on the left by flipping everything. So we flipped the sign here when we divided by a negative number. And then when we got our answer, I want you to rewrite it. Okay, so let's look at number 3 and 4. These are 2 steps. So when we solve for x, here we have a -1. We're going to add 1 to both sides of the inequality symbol. That gets rid of that, and we have negative 3x is less than or equal to 9. Okay, all so far so good, right? These two are best friends. We leave them together, and we got rid of the -1. But now we need to get x by itself, so we need to divide by a -3. So that means we're dividing by a negative number, which means we're going to need to do that flip. So we get x, in this case it's going to be greater than or equal to -3. And that's our answer. Now let's do number 4. Can you tell that we're going to need to flip? Because look, this is a negative number in front of the r, and so we're going to end up dividing by -5. Some of you are going to get very good at seeing right away, yes, we're going to need to flip that sign right there. Anyway, let's solve this inequality and see what happens. So these two are best friends. We're going to subtract 1 and on both sides. So we get -5r is less than 30, right? We subtracted the 1, so we get -5r, and we bring down the inequality symbol. 31 minus 1 is 30. Now to get r by itself, we can do the final step. We're going to divide by -5. But remember, when you divide by a negative number, you're going to have to flip the sign. So r is greater than -6. I flipped the sign. And these solutions here will make this inequality true. If we didn't flip the sign, though, it wouldn't have worked. Okay, so that's one exception, okay, is when we divide by a negative number. Well, when we multiply by a negative number, we're going to also have to flip the sign. So whenever we multiply or divide by a negative number, we're going to have to flip the sign to keep the answers correct. So in numbers 5 through 8, to solve these inequalities, we're going to end up having to multiply at some point by a negative. Okay, so we have x divided by -10, so we're going to need to multiply by -10 to cancel that. So we're multiplying both sides by -10. Well, we're multiplying by a negative, so we're going to need to flip that sign. So we get x. Now flip that sign, and then 5 times 10 is 50. And it's 5 times a negative, so it's -50. Number 6, we have n divided by -3. We need to get that variable by itself to solve this inequality. So we're going to multiply this side by -3 and this side by -3. So we get n, and we've multiplied by a negative number, so we have to flip this sign. It needs to be written like that now. So n is by itself, flip the sign, and then we have -3 times -4, which is +12. Okay, and then do I want to see the variable on the left? Yes, I do. So please remember to flip everything around so that the variable's on the left. Number 7 and number 8 are 2 steps, and they're very similar. Here we need to get the x by itself, like we always do. These two are best friends, so we'll subtract 5 and subtract 5. We get 1. Bring down the inequality sign. That gets rid of that. We have x over -9. We're almost done. We need to get x by itself. It's being divided by -9, so we'll multiply by -9 on both sides. And that's going to give us x. But we multiplied by a negative, so we need to flip the sign. So instead of greater than or equal to, it's less than or equal to. And then 1 times 9 is 9, and it's a positive times a negative, so it's negative. That's our answer. The same thing with number 8. Notice, though, that the variable is on the right. These two guys are best friends. We need to get rid of this -2, so we're going to subtract 2. Or this +2, so we're going to subtract 2 on both sides. And we get r over -2. Bring down the symbol. 7 minus 2 is 5. We're not flipping anything yet because we're just subtracted. It's only when you multiply or divide by a negative, right? So now we're going to multiply this by negative 2 to solve for r. Multiply by negative 2. Multiply by negative 2. And we get r, flip the sign, and negative 10. Now, we flipped the sign because we multiplied by that negative 2. And we have the variable on the right. This is not wrong, but remember, I really want you to be in the habit of flipping everything around so that the variable is on the left. And notice the point is pointing to the r here, and when we flip everything around, the point should still be pointing to the r. These two statements mean exactly the same thing. Okay, it's just that the variable has now been written on the left. Okay, one last one. We're going to solve this two-step equation. And this is one of those ones where these two are best friends because they're on the top of a fraction. So we have to multiply both sides by the negative 3. So we're going to cancel that and cancel and then write it over here. We have negative 5 plus n is less than, oh, we have to flip it because we multiplied by a negative 3. So it's negative 5 plus n, flip the sign, and we get negative 9 on the right. So whenever you multiply or divide by a negative number with an inequality, you've got to flip that sign. So now we have negative 5 plus n. To get rid of this negative 5, we'll add it. And we get n is greater than negative 4. And remember, we don't have to flip the sign because we're just adding and subtracting at this point. We had to flip it, though, earlier when we multiplied by negative 3. And there's our solution. And remember, sometimes we have to graph our solution. So if n is greater than negative 4, we're going to put a bubble at negative 4. And we want all the numbers greater than negative 4, so we'll shade to the right. And because there is not an equal sign, we will not fill in the dot. Okay, that was a longer lesson, and it's challenging. Let's see how you do.